Behind the hood, beyond the arc, and past the sparks to talk shop with industry insiders who bring real-world experience and a unique perspective to every topic. This episode is sponsored by Fusion Grip TIG Torches, the Discover Welding online learning program, and by Florida Gas Welding Supplies. We appreciate their support in helping us bring real conversations and real industry insight to the welding community. All of our guests join us in their personal capacity, and the views they share are their own. This Weldcast exists to educate, inform, and support the welding community. References to tools, products, companies, or sponsors do not imply endorsement by our guests, their employers, or one another. Nothing in this Weldcast should be taken as instruction, technical direction, or engineering advice. Always follow the appropriate safety standards for your work environment, including ANSI Z49.1, ANSI Z136.1, and all manufacturer documentation, including owner and operator manuals. Only perform work within your training and qualifications, follow all warnings and labels, and seek formal instruction to advance your skills. Welcome back to the Sparks and Spatter Weldcast. This is part of the Laser series. And in this episode, we sit down with Ryan Losey, who's the Weld Shop Manager at Phoenix Laser Solutions in Grand Rapids, Michigan. Ryan's micro laser welding clip went viral on the internet and generated a ton of questions and comments. He initially got his start doing high precision TIG welding for the marine industry, before transitioning over to Phoenix Laser Solutions, where he splits his time between arc welding and the micro laser welder. Ryan breaks down how TIG welding skills translate directly into micro laser welding and why feeling the wire still matters. He also talks about how early laser systems, big, expensive, and demanding perfect fit up, have evolved into compact, forgiving machines with better wire feeding, improved gap handling, and dramatically easier usability compared to even just 5 years ago. We also dig into safety, the difference between arc radiation and a focused laser beam, and how a 500-watt micro laser compares to the multi-kilowatt handheld and automated systems that are on the market. If you've seen the viral video clip and wondered what's really happening behind that tiny controlled weld pool, this conversation takes you deep within the process. All right. We're recording. So Ryan Losey, welcome to the podcast.
Thank you, sir.
We're glad to have you.
Yeah, good to be on. Thanks.
Yeah, absolutely. I was down and visited you at the shop the other day, and you gave me quite a tour and an education in some micro precision laser welding, and that sparked some interest online. So we've got lots of questions for you.
Sure did. Yeah, it's a very, not a very niche world, but it's not one that people, they don't think about it every day when it comes to TIG welding. They think of precision and pretty, but then getting real fine with stuff brings it into a whole nother category.
Yeah, it definitely did that for me, and I had a little bit of trouble holding on to that small little wire, so that took some finesse for sure. Yep. So let's start out. I want to just go over your background again. So when did you start welding in the first place?
Yeah, I probably started, I'd say about 15 is when I really started with it. Snowboarding got me into it. I used to like to hit all the train park features and wanted to learn how to build a rail, and putting two pieces of metal together makes welding your application. So that's kind of where it brought me into it, and then started with our local tech center. They had some summer camps that were just like a day to get your feet wet, kind of get you interested in possible classes that you could take in junior and senior year in high school. And then our high school actually lucky enough to have a metal shop in high school. So that really brought things into perspective of I want to do this, and then went into tech center, did that for 2 years, and decided that I was going to go to Ferris, and had you for a year. And, then I did the second year for the associate's degree. And then my plan all along was to get the piece of paper that, gives you the pat on the back for people, and then get out and get in a world experience. So
yeah, you wanted to build stuff, you wanted to make stuff, and you wanted to see it come together.
Yeah,
And
The
you stuck to your guns.
yeah, the technical side behind it, knowing, why things are happening, because I've seen it with my own eyes is really where I wanted to be.
Yeah, yeah, getting firsthand experience under the hood, and
Mhm.
now you were welding when I met you, or shortly after that, doing
Yep.
some precision stainless work, starting out kind of in that, like you said, the pretty TIG world.
Correct. Yeah, I started doing marine application stuff for Tierra yachts and Pursuit. So all stainless steel and aluminum work for them is
Oh,
kind of where
gotcha.
I got my first job in the field.
Yep, yep. And when you graduated, you jumped ship or jumped boat, so to speak, and went for more challenges.
Correct.
Okay, okay. And where are you at now? What's your job title? What are you doing these days?
Right now, I'm running a small weld shop in Grand Rapids, Phoenix Laser Solutions. So we focus on laser welding, um, also with some micro TIG, and then laser heat treating at our facility.
Oh yeah, so you're doing multiple things with laser technology.
Correct.
And you started out as an arc welder, went through the welding program, and you've jumped over and kind of adapted the laser skills to your skill set.
Correct. Yeah, having the fundamentals, you know, like anything, you got to have your stepping stones. So start with oxy fuel welding, go from there to stick welding, from stick to MIG to TIG, just kind of bring it all together. And really, all welding comes down to is watching the puddle. Watch the puddle, see what the puddle's going to do. And then in a laser, that's the same way. You watch the puddle, and it's just at a much smaller scale.
Yep, yep. You got to have the scope there to bring it all into focus. But that's right, and I think lasers are a little bit different energy source, if you will. There's some mystique and mystery about them because they've historically been expensive and exclusive to only select shops.
Mhm.
But it is just welding, right? At the end of the
It,
day, we're still joining material, and like you said, it's one other process of being able to lay something down. That's kind of cool too.
yeah, and it's a fully metallurgical bond, so it's not like a thermal spray application where, yes, you have this different power source, energy source behind it, where you're, spraying material over and you're not actually melting into the base material and getting a good admix.
Oh, yeah,
So, so
actually,
with laser welding now, you're getting a true admix between your filler and your base material.
okay. So it is fusing it. It happens really, really fast. So you're hitting it
Correct.
with quite a bit of power for a short time, pulsing that on,
Yep.
and then you're able to machine it right after that. In
Cor-
many cases, with the work you're doing,
hmm
and you're avoiding preheat in a lot of cases. Was I correct
Correct.
in some of those areas too? I was
Yeah.
amazed by that.
Yeah. So your typical, in my application, most of my stuff is going to be tool and die molds. In for most of the stuff that I do, some shaft work, but a lot of the materials I'm seeing are tool seals. D2s, A2s, high carbon areas where, especially right now, a lot of it's all coming from China. So they call it an A2 or a D2, something that is, typically in the TIG weld, you're getting a preheat of, anywhere from a minimum of 550 up to 900 degrees, and to prevent cracking. And now you're getting rid of all of that. So no
Wow.
preheat, and you can put on a rod that's gonna, after machining. So yeah, for the most part, with the rod that you can put down, it's gonna be coming out after machine at low 50 Rockwell. So they can
Oh,
take it right from machine and put it right back in the press.
wow. So that it saves a lot of time and potential distortion. I guess you're going through different thermal cycles with a traditional process.
Correct.
And you still TIG weld, right? Am I right there that your
Yep.
TIG welder has a bumper sticker that says "My other welder's a laser"?
It does. Yeah, I
But
mean,
that
half the time I'd say I'd say about half. I'm welding TIG and half I'm laser welding.
Okay, so still dividing the time back and forth, and I'm partial to the Dynasty 300 that you have on site there. That's kind of cool, and I
Yeah,
even remember seeing a MIG machine there. So we're not throwing arc welding out the window in this case,
correct.
but the laser really adds capabilities and lets you get stuff done quicker
It
in terms
does.
of that micro world.
Yeah, and especially for in the mold side, with plastics and even some rubbers, their tolerances are you know half of a thou,
Yep.
and if that half of a thou isn't squared off quite right, then they're going to have issues with plastic pushing through. So we
Yep.
have we have more, um, with the downtime that they have with TIG welding. You're putting on. I know guys that'll TIG weld with 10 thou wire micro TIG under a microscope and get in after it, but you're going to have a bigger heat affected zone, and in plastics you can't really have heat effect zone.
Because you see it in the final product.
Correct. So
Okay.
in the plastic world they call it color match. In your plastics you can see a different where the heat effect zone is, and so in the plastic you can actually see a different color.
Wow. Yeah. So lasers give you that capability to avoid that. You minimize
Correct.
that discoloration.
Yep.
Not as much. We'll call it polishing when you're done.
Correct. And with the laser, I mean, I had a couple jobs today that you're just doing a fine edge bead, and so they're only going back in with a hand stone just to dust it right off. And so even in the heat affected zone, because there still is a heat affected zone with laser welding, it's so minimal. I added 2 thou to an edge, and so that 2 thou is going to be quarter of a thou, um, of a heat effect zone on the edge there. So
So it's
nothing that you would ever see.
really narrow and not causing any stress, or you don't see underbead cracking or anything like that because it's so
Correct.
controlled. That's
Yep.
amazing. That really is amazing. And from what I understand, there's been companies that have been doing tool and die welding with lasers for years.
Correct. Yeah.
But
So go
what's
ahead.
changed about the equipment, or what makes it better today than it has been?
So the guys that started, using them commercially on a regular basis were jewelers. They were welding the rings together, putting little, pendants, your little spikes that hold your, big centerpiece diamond up. And they were starting with 50-watt lasers, 120-watt little super micro lasers where they're actually using it just for solder.
Yeah, they're
So
not really getting that bond you were talking about where you got the admixture.
correct.
Yeah.
So after that, people started realizing that you can do super small, precise edge beads and molds, and different applications where TIG welding may just be too much. So they started bringing the size of the equipment up to give you more power, so that then you could weld bigger, objects as well.
Oh yeah. In fact, that's the first. You can't really call it handheld laser because it wasn't handheld, but it was manually operated. The first one I was ever involved with was a jewelry laser, like you mentioned. Put your hands inside and held pieces together, hit the foot pedal, and wham, it would put a spot down.
Yeah.
And
So
they were
that's
pretty expensive.
yeah, that's how they kind of came to the mainstream market.
Okay. And then tool and die became a logical step for that micro precision work, kind of like you would also want in your jewelry, I guess, so it's invisible.
Yeah, correct.
And the ability to weld
So,
exotic materials.
yeah, I mean, in my world, it's normal materials, high nickels, high carbon stuff that is prone to cracking.
Yep. Yep.
With
And
a
needs to be very tight tolerances.
Yep, with a pulsed laser, the heat effect zone, like we already said, is so minimal that your quench rates aren't they're hardly existent.
Yeah, yeah. Um, so as you're welding this stuff, like coming from the TIG world, I'm used to argon. So I'm thinking everything's got argon around it. Are you using argon as well with your process?
On my machine, I am using 100% argon. Yep.
Oh, okay. Do you use other gases sometimes too?
I do not. Everything that we do is 100% argon. Sometimes you put a trailing gas as well.
Oh,
So you can actually have two nozzles. You can have your leading edge and your trailing edge, so you can kind of flood the area with argon.
oh, okay. All right. So that's kind of more like you said, traditional trailing shield you might see with titanium or something like that.
Correct. Yeah. Some of your Inconel high nickel alloys where you need that trailing gas.
Okay. Okay. So some of that does translate over, and that how to deal with metals from the TIG side probably gave you a head start as you jumped into it.
Correct.
Okay. Hey, do you ever do aluminum with this thing?
We do. Yep. So aluminum, aluminum bronze, beryllium coppers. Um, I call them gummy materials.
Gummy materials.
So when I'm welding them, the um, all the impurities, because you don't have like on a typical AC where you have a cleaning current, if
Right.
you don't have the materials super clean, all of the impurities kind of come to the surface and it makes the weld kind of gummy.
Looks trashy.
Yep.
Yep. And that's big on aluminum and like you said, copper and some of those other metals.
Yep.
The gummy
Correct.
stuff.
Yeah.
Ooh. Yeah. Yeah. Because
It does weld a little different, and when all those impurities come to the surface, it kind of just wants to ball up and be nasty on you.
yeah, you brought up a good point. With TIG welding, we have alternating current, which gives us a little cathodic cleaning action next to the
Mm-hmm.
weld. So even if we're less than stellar with our stainless wire brush,
Yep.
we can get a little cleaning from the arc while we're doing it. But AC doesn't really come into play with laser. You've just got a heat source there, almost like
Correct.
electrode negative.
Yep.
Yeah. Okay, that's a good point too. That's a good point. And what kinds of stuff do you see out of aluminum in your world?
A lot of the aluminum that I see is going to be um, foam molds for armrest in your vehicles,
Yep.
or a blow mold.
Oh,
So your milk jugs, your shampoo bottles are most of those are a aluminum. Some of them are going to be your 6061s, and I see quite a bit on the blow mold side that's a 7075.
oh, which is a little
So
more challenging to weld with an arc process.
correct. And even with your laser, you're gonna it's not more challenging because you're not dealing with some of your typical attributes of the 7075, but it is a little. I use a 5356 wire on it, and that's a notoriously dirty rod to
Is
from 4043. So it's just a little more structural.
I got you.
Yeah.
I got you. So that's where you're building threads and stuff up, aren't you? Inside those molds,
Some
you
of
have
them,
to.
yeah.
Yeah.
So a lot of those blow molds for like your milk jugs are going to be aluminum bodied, with their pinch points are going to be beryllium copper or some sort of material like that.
Okay. Okay.
Mold,
So
some use Mold Max, some use Ampco. Um, just depends on what the end customer requires.
gotcha. And you got to pay attention to where that material's coming together and
Correct.
everything. Okay.
Yep.
Yeah.
And, and
That's
underneath the laser, with the magnifying, we're magnifying 10 times at least. And, so you can see everything, where a material starts and stops, even when they're having those tight tolerances on machine.
right down to to the parting line.
Correct.
That's pretty cool. I love the technology and the precision of the welds you were able to put down there. And then you put me in the driver's seat and humbled me as a TIG welder going over to that micro world. But it was, I'm not going to say it was easy because it has a whole different set of challenges to my world of TIG welding. But I was able to do it relatively quickly with your guidance. Did you find that too, that you could jump right in and start doing it?
Yeah, all of it has a little bit of a learning curve. That first, for sure the first day is, you're going to have some highs and lows. And I'd say that first month, you have days that are great and then days that kind of come at you and it's like, do I even know how to weld? Sometimes you're fighting too much and, you just kind of have to go back to the basics of, look at the weld and watch the weld and see what it's doing. And having on our system, how you were driving, welding away, and I've got a camera that goes on it and I can physically see on a TV that's off to the side, see what's going on. And if you have somebody that knows what they're doing on the laser welder, I'd say within a week you can start to be pretty proficient.
If you're practicing and you take it seriously and you work on improving, you can get there.
Yeah.
Is that how you did it? So when you started, how did you adapt or jump over to that laser?
Yeah, so I did it very similarly. I had the camera on my manager at the time, and he kind of walked me through the ropes of this is how things go, and that really the best way to do it is to get on it, because you're not going to learn just watching it. You have to get hands on, and because the feel is, in my opinion, that's where everything is. You can feel if you're pushing too much wire in, whether you're not giving it enough. I personally can, if I pull my wire out just a little bit, you can feel the wire, take less wire get taken by the weld. If you're pushing too far, you can feel it start to kind of gum up or kind of sit high on you.
So, it ball up a little bit more than you wanted.
Correct.
Customer doesn't like that when they only wanted a few thou on there.
Yep.
That's interesting then too. So even though it's really delicate, you are getting that tactile response back where you feel the pressure and you can see what's happening. Just takes some time to do it.
I'd say that your senses are a big factor in it. You listen for how it's sounding, you listen for your gas, you listen for how the laser is actually hitting the material, because you can tell whether it's not hitting it hard enough or whether it's hitting it too hard. It kind of makes a snap sound when it's hitting it too hard. You watch the puddle, you can feel it with the filler rod.
And then you're dialing it in. What parameter do you mainly set when you're adjusting? Is it power level?
So it all equates to power output, joules. So you can adjust your wattage, your milliseconds that the beam stays open and on.
Yep.
You can adjust your hertz for how many times it's pulsing per second, and you can adjust your spot size as well.
Oh, so you've got a few parameters to control. That's got to take a little bit of time to dial in, huh?
Yeah.
The recipe for success.
And I'd say that there's always a starting point, whether you're TIG welding, stick welding, MIG welding, you've always got your kind of set point where you can start and put down a decent weld or at least be in a good starting zone. And then you kind of fine tune from there.
Yeah. Okay, get in the zone. Because I remember with that jewelry laser I worked with, they had a sheet of paper that had all those things written down for all their different materials, almost like a weld schedule.
Correct.
And so I'm guessing you get, as you try different materials, you start to build that list.
Yep. And, a lot of it comes from what what the material is like. I mean, some customers tell you that it's a H13 material, but they don't tell you that it's nitrided. And
Oh.
you find that out as soon as you shoot your first beam at it. And it just kind of makes a big bubble and looks all nasty. So you either have to take a die grinder and take material away and then build up, or sometimes if it's super shallow, you can take the laser beam and kind of eat it away to kind of take that nitride out, and then it'll still sit lower, but then you have to build it back up to shape. So,
yep.
Different materials definitely have different settings. It's
Yeah,
not just all or nothing.
And you're using it as a cleaner when you need to, it sounds like. So
yeah,
you develop those tricks.
Yeah, not the primary use of it, but sometimes you have to, eat away at whatever the coating is. Some of them leave a bunch of oil on it, and if it's a super porous material, acetone can only do so much to get it out.
Because it's going to be in there.
Correct.
And you're going to find it with a laser.
Yep. And you would find it with a TIG welder too. So
sure,
that aspect of it is pretty similar too. So your material prep is a big thing for it.
Yep, that makes sense too. So lasers make things possible, but they're not miracle workers, so to speak. You still have to take the time to do your prep, and the cleaner it is, the better. And I think on aluminum, I'm hearing you have to be a little more careful than maybe with TIG welding.
Yeah, you can wire brush so much, but sometimes in my world, you can't wire brush because you're going into, say, a textured surface.
Yeah. So how do you clean that kind of material when if you scratch it, you're in trouble?
So those ones is kind of run a pass and see how it's going to take, and just try to get it as clean as you can.
Yeah. Have you ever been successful, or have you ever tried using any chemical cleaners, or are those even too aggressive for the surface?
Some of the surfaces they can be.
I know when you're dealing with expensive tools and molds and stuff like that. Yeah, you don't want to take too many risks.
No, especially with the cost of diamond polishing certain parts or getting something retextured.
Yeah, absolutely. So when you started there, how much laser welding experience did you have before you jumped in the seat?
None. I didn't even know that laser welding was, of the small, or I guess the mid-range scale that it was.
Yeah.
I had heard about at that point, the light weld was, super new. So everybody was all raving about the light weld, and kind of seeing some of the downsides of the light weld as it came out. Just on the usability, like the customer couldn't take it and have an out of the box machine. Like everybody that I personally knew that was running one was having issues with, the wire feeder on them, which they've since fixed. But
early on, it was a challenge.
So, guys are spending $25,000 on a light weld, and then they're having more downtime with them than if you were to just MIG weld it or TIG weld it. So my laser thought at that point was kind of, is this going to be a crapshoot, or is it going to be, the next best thing since sliced bread?
Yeah. You bring up a good point, because a lot of new technology, whether it's good or bad, is kind of determined how usable it is. And if it gets shoved into the corner and nobody's running it, that was not a good investment, despite the potential capabilities it could bring. I'm with you. My experience was big, huge lasers, maybe mounted on a robot. That was about as scary and dangerous as we got. Fully enclosed systems. So they were very dedicated, very expensive, and typically, like we've discussed, only used by high-end shops, high volume, high production, that kind of thing.
Yeah.
Power hungry, gas hungry. There was many reasons why I was like, nope. And then I saw the light weld too, and it as an arc welding instructor working with students that have never had any laser training, I was concerned first about safety.
Mm-hmm.
Absolutely. And then second, how's this going to work in production? So
Especially like up at Ferris. Oh, sorry, dog's going crazy. Can you hear him?
yeah. I'm interrupting your evening time now, so it's understandable.
That's all right. Yeah, he goes crazy when everybody gets home.
Yeah, usually it's my dog barking. So I'm glad that I'm not. Mine's quiet. Knock on wood.
Yeah.
Right. Only for a minute.
Yeah, you say that and then they'll start barking.
Probably at each other.
Yeah.
Yep. Yeah. No, it's going good though. It's going good.
Yeah, I was just over in Milwaukee for the weekend, so drank
some
beer,
you?
ate some brats.
Good deal. What were you up to over there?
Just a little anniversary trip.
Oh, nice. So you guys went on a vacation.
Yep, just did a little, just regular weekend, left Friday and came back Sunday, so.
Cool. Did you take the boat over? Did you drive over? How'd you get there?
Drove it.
Oh, yeah. Then you're on your own schedule.
Yeah, because otherwise, you got yourself a 2.5 hour boat ride, and these days it's $400 for a car and two people.
Yep. We would always say that too. If I was floating over and it was just me and I could get a discounted rate, it was worth it. But otherwise, it was better to drive and have a car.
Yeah.
Well, cool.
Hey, things good. Mike, all good. Dog quiet down.
Yep. We're at 29 minutes of recording, so man, we're on track here.
Cool. Yeah, I'd say from Ferris, the only laser exposure that you really have is, at least in the 2-year program that I experienced, was the laser cutter that is, in its own little box that's in the corner. And it's, they pretty much teach you that when that thing goes hot, watch out, it'll cut you in half is pretty much the way that they try to scare you with it.
Yeah. And they did drive safety home in the program there.
And totally understandable. I mean, when you're dealing with a super focused beam of energy like those are, I mean, you're taking a 6 kilowatt machine and you can cut some serious material with that stuff.
Yes. And they're focusing that energy down to a real small spot size. Yeah.
And, on the topic of safety, we had a guy that, I knew, and he got hit with a laser on his finger, and it did some damage.
I was talking with Donovan Stein the other day, another student, former student that's working with Abacore Benzo, and he said the real danger isn't getting hit by a poke like you'd get a sunburn with welding, arc welding radiation, mainly UV, but the beam focus could be in the middle of your finger. So that burn's going to go through that tissue potentially, even if we don't have more catastrophic issues. You're going to have a blister that runs all the way through that area.
Correct. Yeah, I mean, the good side about it is that it cauterizes it.
Oh, so it's clean.
Yeah, but you don't want that to be happening. But it's, I know that all the safety is, it's all there for a reason.
Sure. Even with arc welding, there's lots of safety out there. People still sometimes have accidents. There are unforeseen things that can happen.
Correct.
No different with a laser, maybe a little more serious in some cases.
Yeah, especially when you get into the big machines. I mean, you've got machines that are, big power, all focusing down. I don't remember all the accurate numbers off the top of my head, but there's somebody in West Michigan that they're trying to get a laser welder out of the Middle East that can supposedly, now don't quote me on the numbers, but I think that they can weld single pass full joint penetration, like 1.5 inches.
Yeah. Yeah.
And,
Yeah.
that's just kind of the start of it. Like, I could see it going into the possibility of like shipbuilding stuff, putting big plates together, having complete joint penetration in one pass. But the safety that comes with it is a whole different world than, my little 450-watt, 500-watt lasers that I'm really dealing with on a daily basis.
So that's another thing too. Power level really comes into play here. What you're working with is doing real delicate work. It's got power, but it's controlled. It's small, micro designed. These systems that are doing 1.5 inches and thicker, single pass, square groove welds with no prep. I mean, that's phenomenal. Just to think about, but so is the power that comes with it, and that, of course, is where safety is even probably the highest that we're going to see.
Yeah,
safety requirements, I guess, and potential hazards.
Yeah, I mean, like forget who the big one that I've seen online right now is. I think it's X Tool. It has their little handheld welder, kind of for the small shops, the guys that don't want to, dump big coin on the handheld ones.
Sure.
And all you need is a pair of goggles and some gloves. They recommend, I think that in their safety manual, they say you need long sleeves in that. But, a lot of guys aren't wearing it, and the risk isn't necessarily there.
So, and help me wrap my head around this, because again, if we're talking arc welding, we've got an arc, and that anywhere you can see that arc, you're getting radiation from it because it goes in all directions. Mm-hmm. Whereas a laser beam can literally go right by, and it doesn't have that scattered. It's focused. So it's columnar, it's coherent, and that adjacent radiation isn't the same danger that it is with arc welding. But if the beam is reflected or you're in the wrong position and you take a direct hit with the beam, that's where we start to see more of the safety issue.
Yeah.
Okay. Because there's been a lot of questions about safety, and I think, as someone who's been through training, but years ago, and like I say, the first shop I went into, we're doing jewelry work, and the owner says, "Hey, come here, stick your hands in there, hold them underneath this class 4 laser, and press that button." And I'm like, is this safe? And I knew enough to ask the question.
I mean, all that was probably protecting you was a thin pair of gloves that's attached to the cabinet, right?
Yeah. No, we didn't even have gloves. But he said there's a shutter, so when you press for a pulse, and we were holding the parts far enough away that he said by the time you get a reflection, if you would get a little zap, but it wouldn't have enough power to do anything more than about a bee sting. He said it doesn't happen very often, and the focal point is so narrow that once you get beyond that focal point, it's scattered enough that it can't do damage, or it's much less dangerous. And I took his word for it. I stuck my hands in there, and I still have all my digits. But it did make me wonder, right? And when the video that we captured when you were there, a couple of them are actually a combination up about 2 million views. And probably one of the biggest misconceptions is that being around a laser, you're getting scattered radiation, and it's different than that.
Yeah. When you're dealing with, the smallest wire that we can purchase is 3 thou. So to be able to burn, one hair. So to be able to focus your beam to, the size of one hair, that radiation isn't what people think. They think that, as soon as it comes out of the lens, that it's just wide open and it's like a gas, kind of like it's just going to go anywhere.
That's a good analogy, right? Like a gas, like it's gone everywhere, but it really hasn't. It's stayed focused in that area. You do have to pay attention to some things you pointed out to me with that. I'm going to call it overshooting with the laser beam, or washing. You said that sometimes it'll hit in areas where you weren't expecting.
Yep. Yeah. So washing, I most commonly call it splash.
Splash.
So
Okay.
so if you're, trying to weld something up on the top corner and you got the wrong angle, so you're not going 45, and you're kind of coming more vertical with it, it'll
Yep.
kind of wash that material out that's underneath it. Even though you're still welding up here, you're getting some reflection off your beam, and it could go into areas that you don't necessarily want.
Right, right. An area that didn't intentionally need to be
Yeah.
one reduced or well, it makes me think about undercut sometimes. If you have the wrong work angle with an electrode, you can get undercutting near the weld and it
Mhm.
sounds different but similar to
Correct.
something you have to pay attention to.
Yeah. I mean, it's a very real possibility that if you don't have the right angle, right settings, right rod pressure going in, that yeah, you can have. I would call it undercut at the toe,
Yeah,
um,
yeah.
or it could be a lack of fusion because your beam's hitting on your top edge and you're not pushing the power down to the bottom edge.
Oh, and then you do just
So,
get that sitting on the surface kind of result.
yeah,
Yeah. So that's another thing to pay attention to as you're dialing things in. Make sure you're getting that wetting all the way through. And you're doing that by eye through the
yeah,
scope, right?
yeah.
Yeah.
And to the safety point,
Yeah.
you know, I'm not sure with the like the handheld lasers that you buy that most people are kind of seeing online these days. Not
Yeah.
sure what type of safety equipment come with those. Like if they come with a certain set of glasses that's OD rated for that machine. Um, but like on ours, when you look through the microscope, there's a little shade shield that's an OD rated shield. So you have your shutter, which shuts off the beam and gives you those pulses. But then every time it pulses, that little lens gets a charge and then it darkens it. But because it's going so fast, it doesn't actually look like you're going
So
dark.
you don't notice it, but every
Mm-hmm.
time that is emitting a beam, it's giving you protection there.
Correct.
That's
So,
that. Yeah, that was impressive trying that system.
and I mean, you can go the second, go one step further and put on a pair of safety glasses, which never hurts.
I have done a little bit of research into that, and in fact, I talked with another guest on the Weldcast regarding safety, and the consensus was depending on the type of laser you're working with, you get a spectral safety glass that will protect you.
Mm-hmm.
And in talking with Donovan too, he mentioned he likes to have extra protection when he's working with automated cells at high power. So he was getting something that had a really broad range for protection.
If you're in a shop that only has, one, maybe two kinds of lasers, you can get away with going to the highest required rating on your safety glasses. But if you're in a shop where you have, a wide range, then yeah, getting a broad spectrum glass, safety glass, is definitely the way to go.
One of the things that we talked about in regard to safety along the lines of what type of protection you need for your eyes, especially with the handheld systems, it was apparent, and you shouldn't use a welding helmet because it doesn't provide the same protection that a laser helmet does. So there's that distinction between the two. And just today, I think I was looking in the welding journal and I saw that Vestalpline or one of the companies had come out with a arc welding and laser helmet all in one. So again, I guess that would be more applicable to a shop like yours where you're doing both. You know.
Yeah. Or, those guys that have the handheld, like the light welds,
Yep.
running
Yep.
something like that, but they're also doing a bunch of TIG welding.
Yep.
So, if you get these guys cross trained on that are, say, on a bunch of this architectural TIG work, like handrails and gates and different stuff like that, these guys are damn good TIG welders, but if you can get a weld that's going to be pretty much ready to be sent out the door with minimal post weld processing. If they can take their helmet from say tacking stuff up on one side of the shop and then come back over and do some laser welding after lunch.
And it minimizes the chance the person's going to grab the wrong hood because it works for both. So as technology is improving, we're seeing safety get better. Engineered safety. I know you mentioned the light weld. I know you're supposed to have continuity and plasma detection for it to continue emitting. So they're really checking to make sure there's a valid arc, if you will, or an active beam that's doing something to try and prevent accidents from happening.
Mm-hmm. Yeah, I'd be curious to check out that helmet, just see what their price point is, because a lot of your, top of the line TIG helmets are $400 now.
Yep.
So it's like if they're, an extra $100 and you can get some laser protection out of it, might as well.
Yeah. Hey, that's not a bad jump up. I'm wondering the same thing. I didn't see price on it, but now I'm really curious because in all the research and all the discussions we've been having on lasers, I hadn't seen a hood like that yet that was combined. Yep.
Yeah, because some of those laser safety glasses, they can run, depending on if you need prescription or stuff like that. You can go $300 easy. So
and when I went out and looked at a laser safety website, it said, what kind of laser do you have? What wavelength and all that? So it was a totally different language than what I'm used to going out. Hey, I need a number 10 shade. Yep. So a little bit of research goes a long ways, and hopefully whoever you're getting your laser from is going to provide you with some good support there and put you in the right direction.
Yeah. And even if they don't supply, a good set of glasses, if they make it easy enough, whether it's on a machine just right there, right up front, or easy right up front, and the owner's manual say this is the required or recommended, that'd be huge. So,
and in your case, you've got built-in protection. You're not wearing an external hood. You don't really have a need to. And at the same time, you're not doing this in the middle of a production shop with hundreds of people around you. You're usually working off by yourself.
Yep.
In that area, right?
Yeah, you have your own little booth. Each welder, we do like to have a partition between. That way, if there is a reflection off of, Timmy that's next to you welding, you're not getting anything in your, in your eye, or, not that if you're 20 feet away, it's going to be so minimal, but, heat on your arm, every now and then you can feel, depending on what laser source you're using. Yeah.
And I would imagine, since you guys are doing unpredictable geometries, right? You have to you have a laser you can actually drive over to a giant piece of tool steel, don't you?
Yep.
So in that case, you have some unpredictable reflection patterns sometimes.
Speaking on the portability side, I can take a machine that's in the weld world. Most people would probably recognize like a Capture 5 from Miller, the fume extractors. I can take a machine about that size and push it where I want to go. Exactly like a Capture 5. It's on casters, push it right up to a job and good to go. We've got ones that are on train tracks. So a little bit bigger machine, a little more rigid on those machines. For super precise work as well. So
bigger frame, more stable, that kind of thing.
Yep.
Harder to set up.
Yep.
Yeah. So before we jump off the topic of safety, because I think that was a good discussion that we had. When I grew up in the TIG welding world, a lot of guys and a lot of folks, welders today, still don't always wear gloves when they TIG weld. Yep. It's something I try to do because, one, I don't like to get a tingle when I'm TIG welding aluminum and I hear a little tingle up the rod.
Yep.
Right? It can happen, and I try to protect my hands more than I did when I was younger. But I heard from a lot of people doing micro welding, and they said, "Dude, if you got a pair of gloves we can wear, let us know, because it's really hard to wear gloves when you're working with that delicate of material.
Yep.
Is that true? You find that too?
Yeah, I mean, even some of your thinnest gloves that you can buy, say from Black Stallion, just the black cuff with the deerskin super thin TIG gloves that, you know, I'd say about 20 thou wire is about the smallest that I go with that before it's, I'm ditching it for
Yeah.
just so I can feel
Yeah.
dexterity on it.
I was going to say 100%, and 20 thousandths. Sometimes it's hard to feel 1/16 wire with
Yeah.
with the too thick of gloves on.
Yep.
So, and it's one of those things that with precision welding, that is the most important factor, and trying to do it as safely as possible is probably an ongoing challenge. But you're not taking huge risks out there. You're not seeing that same kind of thing, and people might not need to be as shocked as they are when they see you doing this, right?
Yeah, exactly. Because I mean, like we were saying, the energy that you end up putting out for those super small wires, and with it
Yes.
being so focused, I mean, you can pretty much weld right up to your fingers before you can actually feel any heat when you're welding, your 10 thou, 5 thou wires.
Yeah.
But with even your 10 thou wire, it gets so flimsy.
Yeah, it's like a wet noodle. I hated. I would hardly ever weld with 1/16 aluminum because it was so flimsy. So I can only imagine dealing with 20 thou every day as the thickest wire you play with.
Yeah.
It's challenging.
And like, for example, tomorrow I've got a job that I'm going to be running 10 thou aluminum on. And so you're only holding out maybe, 60 thou, 60 to 100 thou, just because it gets so noodly.
Yep. It's kind of like a spaghetti noodle there flopping around, especially when you're looking at it under a scope.
Mm-hmm.
So, it's gone.
Yep. I mean, you do, because you want to control everything when you're going that small. Everything has to be perfect.
Yeah, absolutely. Has to be dialed right in. So, so when you started at this place, I remember seeing the test block that you showed me where there were some practices that you do, and you weld around some corners, you do some circles, which is challenging when you're driving the joystick and trying to follow the wire. But how long did you have to practice that? Did you ever get the Phoenix symbol done? Did you do that?
That actually started after I started, just because now lasers becoming such a big thing. We're trying to have a standard for training, standard process,
Yeah, quality control.
Yep,
and weld qualifications.
Get to the point where, laser beam welding is being called out regularly on prints. So we want to be able to have, assurance that anybody in the shop can get a part that's, fairly, I wouldn't say simple, but, a
routine,
routine
thing that you
us.
guys would see. Yeah.
And be able to go from there. So I haven't done that yet, but I'll definitely have to get on that and send you a picture when I get that done.
I thought that was cool because like you said, you don't just go out to the local corner and say, "Hey, I need 10 laser welders to come over here and start with us tomorrow." So you're doing a training program inside, and all four of you guys that I talked with that day all had laser welding experience. Heat treating experience too. I thought that was kind of a neat application with how you're using some of those lasers.
Yeah.
Because a lot of people asked, how could I get into laser welding? How would I get started at this? And my recommendation is a lot of places would have in-house training, but kind of like where you're at. But it helps to know welding first.
Correct.
In this case.
Yeah, if you don't have a solid foundation of TIG welding or oxyacetylene welding,
yes,
if you have one of those two, it translates pretty easy. Take welding being your easiest, then oxyacetylene welding being your second, and then stick welding's kind of its own creature, and MIG welding's its own thing too. So, I mean, as
Yeah,
long as you
yeah.
know how the puddle reacts, you're usually pretty good.
Yeah, absolutely. So, and how long you been doing this now? Because I lose track of
Just
time.
just over 4 years now.
Okay. All right. Well, I tell you what, I was impressed with the shop that you have down there, especially that giant forklift.
Yeah.
With the lasers that you have, and then the heat treating side of things for doing very localized heat treating when you're done. That was also fascinating.
Yeah.
And yeah, I was going to ask you though, specifically, you said you were using a laser and there was a laser right next door in another booth.
Yep.
And you said yours was a little better because it had newer technology.
Yeah. So the laser welder that I typically use day in day out is going to be a fiber optic power source.
Okay.
YAG is the kind of old school version, but I mean there's no problem with a YAG laser.
Sure. It's what they now just call a fiber laser.
Yeah. So
it's a fiber laser, which is broad.
So the fiber optics, I like them because you can go in really every day until you burn out a power source, which is, it takes some time to burn out a power source. But your weld is going to be consistent all the way through until you burn up a power source.
Whereas otherwise you're getting we're going to call it big words here, degradation, where the energy is progressively going down as you're using it at the same
correct
pump level, if you will.
Yeah, so with a YAG laser, a typical YAG laser, you have your flash lamps, and then when they flash, they go through a flash tube, go out, they reflect back, go. Let me get the correct terminology here.
Right. Things we call them in the shop probably aren't the same as.
Yeah. So I mean, with a YAG laser, when it flashes through the bulbs, you send the desired amount of power to the bulb. It flashes in the resonator, kind of the whole contraption, and then it goes into the flash tube, goes out rear mirror, pumps back out, goes through all your safety stuff, and then hits your deflection mirror, so then you can focus it down to where you want.
To a usable beam then, yeah.
But those flash lamps are expensive, and I'd call them a consumable. I mean, you have X amount of time with it before it's, you may be able to start super low with your power, and then by the time you're getting done with those lamps, when they're getting burnt out, you have to bring up your power so you can burn the same as you were at the beginning.
Yeah, because they're not passing that through as efficiently anymore.
No.
So you're losing efficiency. Yep, just like a light bulb, I guess, over time, maybe burning out. And it seems like with these lasers, we've come from incandescent to fluorescent, and now we're on to the LED stuff too. So they're getting more reliable and calibrating over time, so your procedure stays the same.
Yeah,
I think that's cool. It makes them more usable over time too. You're not chasing your tail.
Yeah, and it definitely makes like running a WPS with the fiber optic laser a lot more repeatable to the customer, because if you say you have I know some people look for power readings. If they want to get real down and dirty with it and have every single T and cross and I dotted.
The Gaussian curve.
Yeah.
3-dimensional energy distribution. Yep.
I mean, it's not unheard of for people to want, power outputs. So if on a YAG laser, if you have to increase power, then you have another step of, okay, well, power starts to decrease at X amount of shots or hours, and then keep kind of tearing down. I could see that happening, especially when you get into like NADCAP,
Oh yeah.
ITAR, where they've got everything that you got to make sure it's all checking out.
Yep. Yep. That makes a lot of sense. So you get into aerospace and stuff, and it gets stringent.
Mm-hmm.
Yeah. So in addition to that, paying attention to that, what's your other consumables that you got to worry about, like laser related? Do you have to change anything?
The most common thing is your wire that you're using.
Okay. So like TIG welding, when everything's working good.
Yep.
But you don't have to sharpen your tungsten.
No.
Which is cool.
Yeah. You have a safety lens on the end of your. So on mine, you have a big circle, and it's got LEDs that illuminate where you're welding, and that everything there is protected with a little safety lens.
Okay.
And if you get a hot spot after running, multiple hours, that glass will start to eat away a little bit. Have a little discoloration, and then that can start to cause some small issues.
Because it's not passing the light through; it's heating up instead.
Correct.
Where it's not supposed to.
Yeah. So you just unscrew a little ring, put a new piece of glass on, put that back on, and then some coolant. It's a self-contained system, kind of like a TIG welder. Check it every so often and top it off with some coolant.
Otherwise, it's business as usual every day.
Yep. And of course your argon gas too. So.
Yes, argon gas. We go through a lot of that, whether we're TIG welded or laser welded, it seems. Awesome. Well, what would you tell somebody if they wanted to get into laser welding? Where would you send them?
It's kind of hard to say because the laser
depends on where they're at.
Yeah, the laser welding field keeps growing every day. I mean, next thing you know, your local weld shop may just have a regular handheld laser. So you could get in it as easy as that, where somebody bought one that they saw online and got a good deal on Father's Day, and brought it into shop. Or you can go to a place that's laser specific. I'd say every big town has a laser welder in it. You just gotta find it.
Yeah.
The style that we do, where it's your precision, super small stuff, but then you go from there, and every town for sure has a laser cutter. So that's an option to get into the laser world. We've got a good gig on the east side with IPG. They got a killer system over there.
They do.
So if you're not able to get hands on, best way to do it now is YouTube. Check out kind of where people are.
Look at what kind of things people are building with them, and you're going to see the industries that are going to go to them first.
Yep.
Right? Like, man, exhaust systems. I can just think if you had good fit up, zoop, done.
Yep. And that's the big issue with exhaust systems. We've got a company in Grand Rapids that they were trying forever to get consistent good welds with a laser welder. And, that was probably 5 years ago that they were really having some struggles. And technology's changed now that you're really getting, a MIG weld fit up on stuff and being able to still use your laser welder. They're getting bigger wires. They are getting smaller laser heads to go on the end of these robots so they can get into different geometries.
So that's taken them places that they never could go before. Mm-hmm. They were limited and expensive and difficult to use. And
I mean, fit up used to have to be pretty damn good.
Yeah, rule was if you want to laser weld, you better laser cut your parts.
Yeah.
Right? You better have that kind of precision. because a gap is going to go right through it. But now I'm hearing the opposite. I'm hearing they can deal with that stuff now.
Yeah. I mean, a lot of, I've seen a lot of guys in auto body using them. Instead of MIG welding with your 025 wire, and having to jump all around.
Spot tacking, yeah.
Yep. There's a lot of welding into those. And I see guys that are welding like quarter panels in with a laser welder. And, there's some wave in the fit up in that. And they just go right over it. And distortion is way less. They're still having to work it back in with a planishing hammer and do stuff like that to take some stress out.
Sure. But it's not a miracle worker.
No, it's not a magic wand that you can wave and say, the metal's not going to move.
Abracadabra.
Yep.
Yeah. But you're not getting the potato chipping that you would get trying to TIG weld or, like you say, MIG weld.
Yep.
And you can get it done faster.
Yep.
That's cool.
You're still playing with the microstructure of the steel. You may not be always changing it.
Yep, we're changing it as much.
Yep. So, as soon as you put heat to metal, it's going to move.
Yep. That 100%. 100. We are welding here, so. But no, that's I'm also coming from the old school thinking. Really shocked about the cost of lasers is coming down. The implementation and capabilities are going up. And like you said, places that 5 years ago were unsuccessful, today it's a no-brainer application for a laser. That's pretty cool too.
It is. It's opening doors for guys that, sheet metal work, especially. You got these guys. You can go online, send a file to a place out of state, have parts cut and bent into your door in 2 days. And instead of TIG welding and having all this distortion on stuff, you can just laser weld it up and send it right to the customer.
That is, yeah. That's definitely exciting for those shops, and it's changing things, changing the way we look at material prep. It's changing the way we look at post-weld finishing. Mm-hmm. And if you bring that into the equation, some people can't afford not to go to laser, right?
Yeah.
It's good. It's going to save them in the long run, upstream and downstream.
Yeah. You, like I just said with the sheet metal example, you don't need a press brake. You don't need a laser cutter, all that. Like, if you can send all that stuff out, but you can still weld it efficiently, jobs are endless at that point.
Yep, so, exactly.
And, you're taking up, the same size as like a Dynasty,
TIG
with
machine.
A water chiller, yeah.
It's not too huge anymore. Not the size of a train car.
Nope.
Awesome. Well, I appreciate you coming on and sharing your knowledge and talking about how you transferred over from the arc welding world and gained the laser skills. You were a ball of knowledge. I really appreciate you letting me try that thing and not laughing too hard.
Of course. Yeah. Next time you're down, come on by and we'll see if we can get some better dimes out of you.
Hey, that's good. Maybe you can get the camera on me too. Okay, that's it for this episode of the Sparks and Spatter Weldcast, which has been part of the Laser series. A big thanks to Ryan Losey for sharing his journey from Ferris State to precision TIG welding in the marine industry and now to tool and die repair at Phoenix Laser Welding Solutions. Thanks again for taking the time to share your experience and insight. We enjoyed having you on the show. Conversations like this help everyone understand where the industry is heading and what's possible with this emerging technology. And thank you to our sponsors, Fusion Grip TIG Torches, the Discover Welding Online Learning Program, and Florida Gas Welding Supplies, for supporting this Weldcast and helping us bring these conversations to the welding community. If you're following our laser welding series, stay tuned. We've got more episodes coming with professionals who work with these systems every day. Our goal is to cut through the noise, talk honestly about the technology, and how these tools can fit into a modern operation. Thanks for watching the Sparks and Spatter Weldcast. I'm Brent Williams. We'll see you in the next episode. Until then, keep your hood down. Don't stare at the bright lights. If you found this conversation interesting, entertaining, or useful, give us a like and subscribe. More Sparks and Spatter Weldcast conversations are coming your way. Thanks for watching.